Hi, this is a question that was asked for instructional segment 1, practice B number 7. So that's what I'm going to do here. So basically says to the graph to the right, what is the average velocity from 30 to 40 seconds? So I'm looking for the average velocity. This is a position versus time graph. So I need to think to myself, how do I get the velocity from a position versus time graph? Well, that's the slope. So, and they're telling from 30 to 40 seconds. So 30 seconds is here, 40 seconds is here. So what's the average velocity here? So basically I'm looking for the slope of that line that I just highlighted. And I could choose points that are from 30 seconds to 40 seconds, calculate that, and that's what I get the velocity. However, I can see that, the slope or the velocity is constant for this line. So I'm going to choose points that are a little easier for me to notice. For example, this point right here and this point right here. So for the first point that I chose, that's going to be at 15 seconds, comma, because I can see it up here, 8 meters. So that's going to be my first point. My second point then is going to be over here, and that's at 50 seconds, comma, 2 meters. And now I can calculate my average velocity using this. So this is for part A. The average velocity is the displacement over the change of time, or the slope of this position versus time graph. So that's going to be let's do 2 meters minus 8 meters divided by 50 seconds minus 15 seconds. So 2 minus 8 divided by 15, or 50 minus 15. So I can calculate that on my calculator here. So it's going to be 2 minus 8, and that answer divided by 50 minus 15. And I get negative 0.17. So my average velocity is negative 0.17 meters per second. So you want to round, and there we go. That's what I get there. Awesome. All right, now let's do part B. So what's the distance the object travels between 0 and 50 seconds? So 0 seconds is here, 50 seconds is here. What's the distance the object travels? And then also what's the change in position, which is basically the displacement. So they're asking me a question that we've done before, which is what's the distance and what's the displacement? So the distance, right, that's the amount of ground covered. So between 0 and 50 seconds, well, it starts at 0, goes to 8. So for distance, I have 8 meters. I just went. And then also, so I'm starting at 8 meters, then I go to 2 meters. So from 8 to 2 meters, that's 6 meters total. So I'm going to add another 6 meters here. Because remember, the distance is the amount of ground covered. So 8 plus 6, that's 14. So 14 meters is the amount of ground covered, and that's my distance traveled. Alright, but now I want to find out the displacement, delta x. The displacement. So displacement, and they're saying from 0 to 50. So displacement just asks, what is your change in position? So for that, well, my change in position, I started here at 0, and I ended here at 2. So my initial position, let's write that off to the side here. My initial position is 0, and then my final position is 2 meters. So the displacement is the final position minus the initial position. So that's going to be 2 meters minus 0. So that means my displacement is going to be 2 meters. And that's my displacement, so that's delta x. So lastly, for part C, it's asking me what's the velocity at 5 seconds. So going back again to this graph, at 5 seconds, that's here, the object is, that's the position is right there. But I'm looking for the velocity. Again, just like I did with the first problem, I can see that the velocity, which is the slope of a position versus time graph, is constant. So I just need to find the slope of this graph. I'm going to choose points that are convenient for me. So I'm going to choose that point, which is the same up there. It's 15 seconds, 8 meters. And I'm also going to choose the point down here, which is 0 seconds, 0 meters. So that's going to allow me to calculate the velocity really easily. Again, the average velocity. It's the slope of a position versus time graph, so it's the displacement divided by the change in time, or the change in position. So my final position is 8 meters. My initial position is 0. My final position is 0. So my initial position is 8 meters. Sorry. My final position is 8 meters. My initial position is 0. And then at the same time, my final time is 15 seconds. My initial time is 0 seconds. So 15 seconds minus 0. So that's 8 divided by 15. And I get 0.53. So my average velocity is 0.53. I could add another 3. Why the heck not? And that is my average velocity. So hopefully that helped. Yeah, see you later. Bye.